Yes, part 3 for CAMWorks. Now we want to program this part. This is the king for people who plays chess. You want to do programming for the king. How well is or how powerful is CAMWorks? So first of all, let me check the overall length. That is overall length is too small. That is 35. Let me check the maximum diameter and the average. This is 11. So what is the procedure for programming on CAMWorks? Ensure you have the CAMWorks, so you go to Add-ins, then ensure that you have checked in the Add-ins, activated. Okay, once you update it to come on this feature manager design tree. So this feature manager design tree, it has this. So CAMWorks 2023, I'm using CAMWorks 2023. First way of programming. So step 1 is activate your add-in. That's our learning objective. Step 2, once you activate, give it time to upload here. It will depend on the speed of your machine, on how fast it will upload, and then it activates on the side for the feature on the feature manager design tree. So next step is define your machine. So I'm doing turning, so I'm using dual. So come here on define your machine. Define your machine. Say yes, accept. So here the machine. You have I can use single turret or dual turret. Let me use the dual turret. Turn dual turret. It has 2 turret, but because my machine normally has single turret, so you can check on your machine when you using single turret. Because machine is single turret, say select. It uploads here. Yes. Then go to post processor. Select your post processor. You have Fanuc, you have Fargo, Haas, Mazag, Mitsubishi, Siemens, Puma. So I'm using Siemens 828. So click select. It is selected. Or you can use 840. Let's use 840 depending on the controller. Yes, good. So I'm using 840D. That is a new controller. Here is the tool creep. Tool creep. It has all the tools. If you feel this tool is not what you want, you can change. You double click on this tool. You click on edit to edit the tool. So maybe this is not the tool you want. You can use DNMG 110404. That is the code I normally use for my tool. You have DNMG 12, DNMG 11, DNMG 15. So that is what it is. The insert, if I say it is 55 degree, here it is 11. Here 4. Okay. So the comment for the insert, it's DNMG, or you can use 12. If you want 12, so I can put here 11. Then holder, I'm using holder of 20 by 20. 20 by 20. That's the holder I'm using. This is standard. So you can check here the rake angle is lead angle, clearance, offset, and then the comment here I can put this as my comment. So which side? So you pick on the side. Which side is your machine? If it is a down right or down left, I'm using down left. So I say I'm using down left. If you are using upper right or upper left, so you pick on which position. This one is for internal turning, but this one here, and this one are for external turning. So you can pick which tool or which direction is your machine. Once you're able, you can also add a new tool. Here, this is a tool I've added. You can also edit this tool. Say edit. Let me put this one. The station is still number 2, but here I'm using DNMG 150408. I can copy this. So let's go one by one. Here it's 55. All of them. I can put 12. It's okay. Then I can put here DNMG 120408. It's okay. Barring. So I can say the bar. This one. This is for internal. That's why you see it is put here. internal. So if it is internal, we can check our answer to be CCMT 070202. If it is internal, we copy this, we come here, internal C, it's 80. C is 80. So here it is 07. So we put 707, not 0.7, 07. Then radius point, I'm using 0.2, 0.2. Thickness is 4, let it be 4 here. So I can check here the code. Then bearing, I can say it is 16 if I'm using internal bearing, but you remember it won't be used. So here it is 125, depending on what you want it to be. Then I can copy there. I say okay. So you can edit your tool clip, or you can add. For example, this I can also add another tool. Say add a tool. I can here click add a tool. I pick which one it is. I'm using the tool is for turn tool. Turn tool. I want to use insert. I can pick here if it is there or not. So you have these other tools which are there. So I can also put this one D. I can also add this, then pick OK. I can add another tool. You can modify, you can remove all of them one by one. So this is your tool clip. If it is full, you can add another tool clip. There are more than, so you can create a new tool clip that you want. I'm okay, I click OK. Yes, that is defining the machine, defining a tool clip, also post processor for the machine. Next is the code system. Code system, automatically I'm setting here. So here it is okay. So there's no need of me changing again. I'm using the part vertex for user defined, not SolidWorks. If you use SolidWorks, it will pick this one, which is wrong for turning. Then I tick okay. Next, stock manager. So if you look at this stock, this is the transparent one is a stock. So material, which material am I use? Basically I'm using aluminium 70, aluminium 60 is okay, 61 alloy, okay, solid. Then here I can add offset. So here it has detected the maximum diameter is 12. So I can say I don't have a stock of 12, I have a stock of 25. So I can put 25 minus 12 is 13, divided by 2 is 6.5. I can put 6.5. So that is the stock. Then facing is 2, can add 2 for facing. For holding 20, can add 20. It's okay for holding. So this is holding on this side, so you add holding on this side. This side is for facing. Facing is too big, I can add 1.5 in case 1.5. Then here 15 is okay. So this one is as calculated here. So this from the offset, and then it calculates to add on this bar stock. Once okay, you tick. So you have done our setup. So the first step in programming is to ensure that you do setup. The setup you do here is the same setup you do in on your actual machine. Good. If you click on the machine, it show me where it is clamped. If I click on the stock, show me the stock. If I click on the code system, it show me the code system. That is how it is. Simple as that. Good. Next is first, just click on extract machinable features. Let it extract machinable features for you. Don't worry. This is the features it has put. It has put turn setup 1 only for left spindle. But if you had a hole on this side, if you, for example, you had a hole on this side that you want to do boring, it will do the same, and then it give you a turn setup 2. Here it has only done turn setup 1. Good. Now this operation, it has rough and finish, rough and finish, rough and finish. I want to create a plan, so click on generate operation plan, so that it arranges rough only, finish only, and it will pick the tool that is available from the tool clip. So to do roughing, finish, roughing, finish. Good. Then toolpath, it doesn't have a toolpath. Click on generate toolpath. As simple as that. Yeah, it has done the operations. All operations are here. If we wanted to do milling, now next we'll go to part 3. This is part 2. Now part 3 tutorial will go to mill turn, so that you can do mill turn. Once you do now your machining, now we'll go to mill turn to do mill turn. But now for this part, I want to show you on how to define a machine, how to select a tool clip, or add or edit or remove, then generate the part, the machine features, generate the plan, generate the tool parts, then do assimilation. But if you don't want to go all these operations, all these steps, here is simplified for you. You can pick one by one. Turning operations, you have turning groove, you have boring operations. As simple as that. So next is, can we do a simulation? We see what it will show you as. We can do 3D simulation, or we can do through step through toolpath. So let's use all of them. For one, we can see how it approaches. Yes, maybe click run, how it approaches. Next, from this stock, if you see where it is holding is not good, check that it is able to hold where you want. For example, I can say this is 40 to ensure that it is far away from the workpiece. Okay, accept, then say update, so that it updates. Then you can click press shift down, this one and this, then you can say generate toolpath, so that it can update from the changes you have made, since this chuck was close to our part. Next is now click on simulate the toolpaths. I want to rotate this part. I want to show you how you can do simulation in real time. Okay, and then this one, these are the display option. For example, the first one is to show the difference. Second one is show all view full. Here is transparent. That's why this one is transparent. I've shown transparent. Then here you are using tool shaded edges. This is only for simulation, not for real part. Okay, then I can reduce the speed here, then run. Yes, very fast, very fast. You see, very fast. But I don't want to do it parting, so when I generate a program, I will not generate it for parting. Why? I want to finish this part. This part, you see, this part, it need to be done. We will do this part on now tutorial 3 for mill turning. Good. So this is what CAMWorks is able to do. Very fast for you. Actually, very fast for you. You see what it does? It has calculated the maximum diameter here, so that it will leave this material for mill turn. So here we'll do a mill turn. This is what it has done for you guys. Let's see. Let's go to now post the process. Post this. How do we post it? Let's say this this posting as .mpf main part file or main program file. Save there, and then I can come here. I want to select all these operations. You click, you hold down shift, select on this, and then select the last one operation, and then click here to play. Click here play, so that it can generate. Once it plays, you can go down here, expanded options, say center line, click on center line, then come down here, check open here, so that it can open. But if you have a machine connected to this controller, you can just run simulation for the machine. But here we can do a generate the program we want to see. Then you click tick, it generates the program for you. Let's see the program it has done. The program must be here, second 2. Yes, it is here. So this part is not needed. You see, it is written this part, it has semicolon at behind it, so you don't need this. So this is the program, and then we can also check the machine, that is Siemens 840D Advanced. So this is a program you can just put direct on the machine. For people who are using Fanuc, has other machine which are not using Siemens language, don't confuse to take this program direct to your machine. It will not cut. This only for Siemens machines. If your machine doesn't understand the language, you translate 0, limit spindle speed at maximum of 3000, and then tool number. For example, if your machine is a machine GSK or has, it normally uses, let me put a semicolon behind, it normally uses T0101, not T01D1. It can be T1, T1D1 or T01D01. It depends. And then if your machine is, you check the maximum speed. Mine is 2000. My machine is maximum speed of 2000. So don't exceed that. That is the maximum speed for my machine. So you can check all these parameters. Like what does it mean by translate, limit, spindle speed, tool number. This is T0101 is T01 is tool number. Then the next 01 is tool offset. For Siemens, it is 01 tool number 1. Then D is the diameter of the tool offset at position number 1. Then G96 is now the cutting speed at 5. Ensure that you limit the cutting speed for the surface to 548. Then the spindle rotated clockwise using 0, M03. M08 means the put on the coolant, flood coolant on. G00, now start positioning your tool when you're doing facing, because this operation is for facing. The first one is for facing. You're doing facing. It goes all the way. Once it finishes, it tells the spindle, go away somewhere, and then initiate, stop the coolant, then ensure that there's no tool. Here, this one, there's no tool offset. Then here, stop the spindle, then change the tool again, because it is using same tool. It goes all the way down the line. These are the programs you can put on a machine. It can do all operations. You see, even tool number 9. So if you put 209, ensure in your machine it is the same as in the same tool station or tool position. So don't change. And then the speed here, it can be 8000 if your machine cannot hold maximum of 8000. So I've not done setup for the maximum spindle speed, because mine can operate that. But if yours cannot operate with the maximum speed of 8000, ensure that you set up your spindle speed first before you generate the program, because you may put this program on the machine, then it will give an alarm that it cannot exceed the spindle speed as it is programmed. Good. That is what it is. Simple part programming for cutting a chess king in CAMWorks on controller 8 Siemens 840D.